Hello everyone. So today we will discuss about a reaction mechanism, okay, or you can say a reaction between primary amine and carbonyl compound. Okay, let's see the mechanism and the product. Okay, let's see. So reaction between we will discuss about reaction between carbonyl compound and primary amine primary amine you can say NH2Z. Okay, so let's see the mechanism. Okay, so this is carbonyl compound, and NH2Z. This is here Z replace here Z is equal to CH3, so we can show primary amine. Okay, so first of all we have to protonate this carbonyl compound. Okay, why we protonate this compound? Electrophilicity increase means after protonating electrophilicity increase of this carbonyl compound. Electrophilicity will be increased this carbonyl compound by protonating. Okay, let's see. Suppose first of all mechanism. This is carbonyl. Here you can say oxygen have two lone pair. Okay, oxygen have two lone pair. Protonate this H plus. So this get OH positive. Okay, and again, or you can say this NH2Z means this attack at that carbon. Okay, carbon. So you will get OH, this and NH2Z, and lone pair of nitrogen attack on this carbon and nitrogen gets positively here. Okay, positively here, and this again you can see here, this acidic H and nitrogen have H plus, nitrogen has 2H, and you can see here one H plus release here, H plus release here, so you will get this OH, this NH and Z. Okay, this NH Z. Okay, you will get here all reactions are reversible, all steps are reversible. Okay, all steps are reversible. Again we protonate and OH minus abstract this H plus, so you will get OH2 positive. Okay, here again lone pair generate this on this nitrogen, so water act as a leaving group here, and nitrogen lone pair donate this carbon. Okay, so you will get double bond and H and Z here, H and plus, and water remove, or you can say water released from this side, okay, of the carbon. and you can say all reactions are reversible. Here we can change small bit, okay, this. All reactions are reversible, and here you can say, here you can see this nitrogen again have H plus, okay, again release H plus. The final product you will get this, okay, final product you will get this. So again I tell you, okay, here carbonyl, firstly carbonyl compound, that means you can say oxygen, we have to protonate this oxygen to maximize the electrophilicity, okay, and again NH2 attack on this carbon and you will get this, and again nitrogen has positive charge, so one H plus release from the nitrogen side, okay, and again OH plus attack, again OH plus OH minus attacks on, or you can say protonate H plus, water act as a leaving group, and again nitrogen have, this side is most important, this step, you can say this step is most important. Again nitrogen has lone pair and donate this carbon and water act as a leaving group, and again nitrogen has H plus, so release finally H plus, and final product you will get this, you will get this final product. Let's see some example, okay, I will explain in next example, okay, so we have to take next slide, okay, here you can see, let's suppose an example, let's see the example, this is PH C double bond O and CH3, and this is NH2OH, means we have to replace Z by the OH, okay, this is called hydroxylamine, this is called, you can say hydroxy, okay, hydroxylamine. So let's see the shortcut, okay, let's see the shortcut. Here carbonyl have oxygen and here NH2, means one H, means 2H and this O, just remove H2O and you will get the product, okay, shortcut trick, okay, shortcut trick to handle this type of questions, okay, pH C CH3 double bond and OH, okay, this is the product. Shortcut trick, carbonyl have oxygen and nitrogen have two hydrogen and oxygen, remove water and the side will be this C double bond and OH, okay, this will be the final product, this is the final product, okay. So let's see another example here, let's see another example here, okay. So again pH C CH3 a double bond O and NH2, this is hydrazine, this is hydrazine, this is hydrazine. So again here H2 and here O, remove H2O and final product will be this pH CH3 and NH2, this is hydrazine, so we will get hydrazone, okay, this is hydrazone, this is hydrazone, okay. I hope you have cleared all the concept and reaction mechanism, all the steps of reaction mechanism, okay. Just this is a mechanism and this is a shortcut trick to handle this type of questions, okay. Just remove H2O and product will be obtained. I hope clear the all steps and the concepts, okay. Bye bye, take care, thank you, okay.